liberation wars going all over the continent. So from the point of view, I'm not talking about South America here, but you can add what was going on there as well. And this looks like an ideal period not to think about fundamental science. Who has money? Who has a moment to think about doing something to just further the knowledge of the curiosity different research? It looks, if there ever was an unrealistic group of people, these are an unrealistic group of people. They're trying to do that. And yes, I wanted to think about the analogy today, because many of the circumstances that I said are correct or will be soon correct in the near future. And again, one could take the point of view that, come on, this is not the time to be discussing about doing fundamental research.
Are you sharing your screen on Zoom? The people on Zoom cannot, if they can hear, but they cannot see.
How can I know what I'm doing on Zoom?
Welcome.
You are welcome to take over.
Try one time for the Zoom people and then we give up. Sorry. Okay.
There is a Zoom icon somewhere down there.
Yeah.
Video is crossed out, right?
Okay. And now, final interruption, I'm sorry.
No, you
Oh,
have to
no.
remove, not final. You have to bring it to the state it was before. It was
Uh-oh.
before.
Help.
Just take a look.
Oh, okay.
You can, I think there should be a button somewhere here. Yeah, this one.
Thank you.
There you go. You make that green bar.
And yeah, you can drag that.
In fact, that video has a big bar on top of doing anything, right? That would just be the camera and stuff.
You want to drag this more?
Josh,
I think there is a,
This looks like a theoretician's problem, resolution to a problem.
Sorry.
Okay. So let's follow this totally unrealistic dream and see what came out of it till today. So first, they decided in 53, before in 54 they signed, to do it in Geneva. But when I say Geneva, it meant that the building itself, where the bureaucrats and some scientists sit, will be in Geneva. But the whole thing was both France and Switzerland. Switzerland was a natural choice, a neutral country during World War II, for better or for worse, that's what they did. And the surrounding around them was France, so it was necessary to have it also in France. And if you're interested, let's say till today, there are lease agreements, so there are 100 hectares in Switzerland and 5 times more hectares in France, which are leased for the purpose of what we have right now. In principle, I should also tell you that the original CERN convention allows for 2 labs in CERN. My guess is, but I have to check history books because there were 2 important personalities and each was supposed to have his lab. In any case, that happened for a short while and then it became 1 lab, but this option is still there. And I hear sometimes some people say, why shouldn't Fermilab be CERN too, if there is such an option? Okay. What are the activities in CERN? So as I said, the main issue is to build an international collaboration. What were the landmark accelerators that were done at CERN? So there was the synchrotron machine. When the first machine started working in 57, CERN was part of a crowded number 3 in terms of its importance. The leading laboratories were in the United States. The Soviet Union was trying to breathe and be from behind, showing, by the way, a lot of, let's say, with less financial means, a lot of improvisation and a lot of ingenuity to try and compensate for that. So this was a real competition. And CERN, together with several labs in Europe, which were there already, was number 3. Then there were other machines built. There was the proton synchrotron. Then there was a machine built in 71, which was my PhD period. It was the ISR. For me, then as a phenomenologist, the main importance were A, that there were rising cross-sections, and B, that one could see at high PT an increased cross-section, more than one would expect. There was a power law fall of the cross-section as a function of PT, and it was a whole industry to see what exactly the power of that power law should be. Now, maybe today, the fact that, I don't know, how many of the young people know that cross-sections rise? The cross-sections rise of when hadrons collide. You know that cross-sections are increasing with energy? I will test you further. Do you know that, for example, they're not allowed to grow faster than log to the 6 of the energy? Okay, so A, that's wrong what I said. I mean, it's true, but that's not the best upper bound. So all these, okay, but it's still happening. So when protons collide at the LHC, the thing to measure first is their total cross-section. That's the easiest measurement. And it increases, and you should know that you should study the Froissart bound and know that it's bounded by log squared of S, or I hope you know what S is. Okay. Then later on, a proton synchrotron, sorry, this I already described. And then later on came the super proton synchrotron, which was, and then the super, on this was built the proton anti-proton synchrotron, which produced the W's and the Z's. And that was really a key point for CERN. Before, there were discoveries, potential discoveries of neutral currents, but it was less clear and it took a while to recognize. While when the W's and Z's were found, the scale was months, from when the experimentalists did it, the experiments, till it was recognized that it happened. Now, so as I said, the ISR, you may not appreciate the theoretical thing it gave, and it measured, but it gave technologically enormously because it was the first hadron collider. So actually, the technology it was there, the thing that actually remained the main heritage of that machine. Then came LEP, electrons, protons, and then the LHC, which is now, it's not through 14, as you know, it's 13.6. And the magnets, it's a risk to do 7 + 7. They're afraid, even though the engineers very much, you can see every time you meet them how their fingers are tingling to increase a little bit the magnets, but it could, if there are quenches, it could bring to halt the program, and this is not what is wanted. So I don't know when will come the moment when some director general will allow the engineers to try and see if they could go a little higher. Then together with this, there are other machines going. It's not only, it's 150 different type of experiments going on there. It has a very diverse physics program. And here, for example, this is an antimatter laboratory. So one may hope that experimentally one finds that matter and antimatter don't obey the CPT theorem and so on, but most theorists are not sitting restlessly waiting for the results, but one shouldn't trust the theorists, and maybe something will come out and present us with a question. But right now, even though the experiments are beautiful and they've produced anti-hydrogen, measured its properties, They're beautiful experiments, but the results from the point of view confirm what the basic assumptions we attribute to conformal field theory are, on which we base this theory. And then there's a lot of nuclear physics, which is also very relevant to processes going on in stars. And this is done at another machine called Isolde. Okay, then this is just maybe the younger ones don't know. There are 4 collision points at CERN. There is ATLAS, which is a large detector. There is CMS, where much of the American community is at CMS. And that's, if you wish, the non-identical twin of ATLAS. In both of them, the Higgs particle was found. Then there is Alice, which does a heavy ion collision, and there is LHCb, which I will describe later, have discovered a very large number of new particles. So as I said, there are many experiments at CERN. Now, what does CERN constitute? What does constitute CERN? So there are 4 legs. First 3 to make it stable. So there is the Council, which is the body which makes all the decisions on policy and finances, which are then executed by management. And all this would not be possible if not an outstanding personnel, which is there dedicated, and I've seen them work 24 hours a day in times when it's needed. So it's really an extremely dedicated group of people. And then there are everybody in the world. This is a lab which has more than 15,000 participants, and the American contingency is the largest. At a certain time slice, it was 1902. I don't know what the fluctuation, what the uncertainty of that number is, but you are by far the largest users of this. Russia was number 2, but Russia has been suspended after the geopolitical events, and this number is now reduced significantly. Now, these are the 4 pillars. Now, what are how does the institute work? So CERN has 24 member states. So the council has 24 members, each represented by two persons. Ideally, one would be a scientist and the other would be either from a funding agency or from a ministry. Now, not all countries have the science. It's not dictated in the convention that the other one be a scientist. So in some countries, it's not a scientist, but in most it is a scientist. The latest member to join us was Estonia on the 30th of August this year, and Slovenia will join us, in my opinion, in December this year, in 2024. This will be my last action, would be to let Slovenia join CERN. Then there are various associate member states, and there are observer states. In particular, the United States is observer. So is Japan. At the time the Russian Federation was, it has been suspended, and the same JINR in Dubna has also been suspended. Now, this is propaganda a little bit, but it's true. The CERN is also a training place for young talent. Many people are at CERN, and look at where the maximum is. It's at the age of 27. So from that point of view, it trains and involves a large number of people. I will let you calculate the average, but I don't think it's very far from 27. Then where do these people go to? So 45% go to industry, 19% come to either improve or complicate the government, and about 36 of them then go to academia. So this is really a place where year in and year out, one is training highly qualified people for the benefit of all those which are involved in the process. Now, what are the organs of governance? So as I told you, there is a council, which is a supreme decision-making authority, and it has itself several consulting bodies. The main one, they're written here, I'll show you afterwards. Then the rules for the president of the council are and the council authority in the convention are very clear and very specific. For example, the term of a president is maximum 3 years, unrenewable under any circumstances. On the other hand, the director general, which in a way needs to implement the decisions of council, but of course she must also bring her own ideas, because the council, most members are not thinking day and night about CERN. So it is crucial to have a director general which comes with ideas and to convince council about how the way forward should be. So the work together between them is crucial. The interests don't always coincide. They can be a little bit different, but one should aim to work together. Then there are also the committees of the director general, which she appoints. And to this, if she would give the talk, she would probably explain that in great detail. I won't take that part, but I will tell you a few words afterwards on the committees of the council. So the council, of course, we need external auditors. The external auditors must check that everything in the organization, which has a budget of more than $1 billion every year, that things are going okay. And the way it's done, each country at CERN has a national audit group, and they volunteer to become, for a period of 5 years, auditors of CERN. And then there is an election. Council decides which of the auditors it wishes to take. Then there are the two important committees. There is a financial committee and there is a science policy committee. These are committees which are subordinate committee to council. Their role, and I told you it's process. The people sitting in council are not experts generically, neither in science nor in finance. And if in science, only on a small point, in a very small area in science. So what one needs are real people which really understand the issues to come and recommend to council if the scientific program, which is approved by the DG and her committees, is actually something that they would suggest that council will adopt as well. So from the finance committee is nationalistic in the sense that there each member state sends its representative, because it's they who will have to carry the burden of any decision taken. So there it's on a national basis. The SPC is on a quality basis. So there are people from Japan, there are people from the US, and they are not supposed to represent from where they are coming. They are supposed to look at the problems which are presented to them and evaluate their opinion. Now we have, for the first time, now he will be 1 more year, Hugh Montgomery, his passport is British, or he has a British passport. I don't know if he has an American one, but his career is essentially anchored in the US. He was the head of Jefferson Lab. He plays a big role, both as a scientist at Fermilab. I think he was deputy director there. So this is it was the first time, a step where the more international, let's say, profile of or portrait of CERN was also manifested in decision bodies of the organization. The others are other things, maybe something which wouldn't appear so much in the US. There is a body where management, member states, and the union sits, because there is a union of the workers at CERN. And the unions do play a role. For example, when there was a financial crisis the result of the Russian Federation invasion, they, for 1 year, agreed to reduce their salaries. And this helps the organization overcome financial difficulties and is only possible in a framework where every year, the member states, the management, and the workers work together. Okay, here you have the various, this is how the council looks like. One had Felix Eduardo Amaldi, Felix Bloch, Victor Weisskopf, many names, illustrious names, were director generals of the organization. Now, I want to show you, I don't hear.
Next director.
I am not a prophet, and since the destruction of the second temple, prophecy was only given to Egyptians.
When?
By the end of the year, there will be a director general. Can I get a glass of water? Is it possible? I see that. Thank you, Josh. Okay, so here, this is a typical, my view of what's happening in council when they're not reading their emails while the debates go on. So here sits someone and says, I don't understand what the hell they're talking about. There will never be the money for this. But then there are those which have the constant angst, both towards themselves and thank you very much. And then how to explain as outreach that sometimes if the result of an experiment is 0.0001 or 0.002 is an enormous difference. How do you get to convince yourself first and then somebody outside that that is indeed an important thing to invest in it billions and billions of dollars or Swiss francs? Then there is just a simpleton physicist, doesn't have much, she doesn't have much expectations. All she wants is a particle. You give a particle, that's it, that's fine. Wants some resonance. Then there are those who are thinking about bringing back to society in a sense that if there would be higher temperature superconducting magnets, and such high field magnets are essential for the future of this, then maybe even the US would have a train system which would work from east to west coast. You never know. Then finally, there are those who say, I think I heard that there is a tunnel to be built somewhere. In my country, there are these 3 companies. Maybe I should begin to think to put them in the bid. So these are the various things which are in the minds of the people which are in council. Now, we are in a moment where the person on the right, which is talking about from where do they think they will ever get this money, is something that worries. It worries people. So the way I can look at it is going back to the past. Now, of course, the past doesn't have to be like the future. In particular, Josh asked me who will be the director general.
I was asking when are you thinking
When
next
I
one?
can promise you the director general will not be the same that was in the past. So things do change. There would be a change. But on the end of my first year, I asked Llewellyn Smith to give a talk about for the education of council about accelerators which performed much less than expected, accelerators which were built for something and found that particular thing, and machines which were built to find something and found instead much more than was expected. And he gladly accepted. He found it an interesting challenge. And in the process, I'm showing you one part which is related not to the big panorama, but to the LHC. So when the LHC was first, when people started building it, first they were willing to say, okay, as long as, first let's have it. So we are willing to work with 1/3 of the energy. Just let us start something. And remember, they had the tunnel there already because the large electron positron collider was already there. So the issue was about how many magnets, how much the magnets would cost. Let's have 1/3 of the energy. Okay. Then came a main question about the detectors. And it was an enormous challenge because you were in the US when we were thinking of building the SSC. And the SSC had a much larger circumference. And on that circumference, the energy needed to find, which was estimated, needed to find the Higgs, allowed to work in much lower intensities because you would get the cross section anyhow. At CERN, it was clear that in this first machine, limited by the parameters of LEP, which are 27 kilometers, the tunnel is 27 kilometers, the magnets are what they were at the time, less than 10 tera-electron volt. It was clear that you would need to increase the intensity a lot. But increasing the intensity gives enormous challenges to the experimentalist. And in particular, it was a golden rule that one should not have more than one interaction point. You're smiling, you maybe remember that. It was, if you have more than one interaction point, forget it. You won't be able to analyze the data. You'll get too much junk and you won't be able to differentiate and find whatever you want to find. Nowadays, the ingenious experimentalists have succeeded to work with 35. So it was proven by some experimentalists that it can't be more than one, and other experimentalists who didn't believe this succeeded to have now 35. So this was an immense success. But in any case, at that time, it was the impedance. It was said, no way. How will you do it? It's too complicated. You will never be able, with such an intensity, maybe you will find the Higgs, but you won't be able to measure it. Okay, then there were, at each stage, and this was written by Llewellyn Smith, who is definitely English. There were two countries which objected systematically to the financial responsibilities involved, the UK and Germany. Impossible. It's not feasible. You can't do it. Till the last moment, actually. In fact, for Germany, this on top happened at a very bad moment from point of funding, but it seems to be every moment of the bad moment. It was when there was unification in Germany. And as a result, they actually got a 10% reduction for a while of their contribution. So not only not to increase, but actually they reduced. The years passed, a lot of struggles. Each time something was done. And eventually, in 2008, something new came up, that machines are human. Namely, the machine suddenly, with all its lovely properties, there was a major quench, which resulted in a 2-year delay in the program. So that again was a question of, do you trust what's going to happen here? Nowadays, what I'm drawing here is the integrated luminosity as a function of time, and in particular, notice 2024. The machine is performing, I think, the best ever machine that was ever constructed. It's beyond what it was designed to do from the point of view of intensity. As I said, from energy, there is a gap of 0.4 TeV there. We hope that it won't happen like in Adone, which just missed the psi particle because they decided the highest energy is 3 and not pi. All they needed to do is pick pi and they would have gotten the psi. The performance is really phenomenal. So this is an enormous success. So what particles were discovered? So first, the Higgs particle was discovered in Atlas and CMS. But I think not less important, there are 72 new conventional and exotic particles which were discovered, most of them at LHCb. These particles are various combinations of quarks, so they are composite. They are composite in various ways. Maybe they're molecules, so they have two color singlets, or maybe there is one color singlet formed out of more, which algebraically at least you can. This is interesting questions, but the main point is there was an immense discovery of new particles. One which maybe is fundamental, the Higgs, and 72, which are definitely composite, but they are new.
Why does it say 64 in the numbers?
Because the LHCb is not the only place. And that's why I added Atlas and CMS as another place where they be found. But the large part of them have been found at LHCb.
Why LHCb? I mean, what's the difference in the detector?
The detector was built exactly to be able to do that. So on top, there were things which are related again a little bit, you can call it to process, but you want to calculate backgrounds in hadron collisions. This requires extreme precise knowledge on how to calculate things in QCD. And indeed, the fact, I'm not going to show you what each of these points are because I don't know. That's one reason. But the main point is that there are no 2 points. Everything is very small margins. And the margins are the difference between various measurements which were done in the Hadron Collider and what QCD said they should be. And this is, again, I think, a spectacular success. So from this point of view, the machine was great. So I would say that today, after the LHC works, not too many countries are saying, oy vey, why did we enter into this adventure? Okay, this did not happen, including the two which objected originally to the idea. Now, what particles were not discovered? So did I show it once, Massimo, here?
Don't remember.
You don't remember, so that's like not sure. So here is a letter that Klein of Kaluza Klein fame received when he got his professorship at Stockholm from his good friend, Pauli. After you read it, I'll let you decide if you want from your good friends to get such a letter. So it says, I'm not of the opinion that finding new laws of nature and indicating new directions of research is one of your great strengths. Okay, that's the way it is. Although you have always developed a certain ambition in that direction. I find much more beautiful those of your papers which deal with applications of known theories, such as, for example, the paper with Mishina about the new scattering formula, etc. Okay, so this was the letter that was received. And as I should mention that Pauli worked on Kaluza-Klein series, but he probably thought that Klein and Kaluza weren't worthy of thinking of that. In any case, we got a similar letter, I think, from Nature. Or the committee of Nature upstairs sent, at least on the basis of the result of the LHC, sent us a very similar letter that we should calculate cross sections. QCD works great, but ambitions on what are supersymmetry, new particles, and so on, not right now. And indeed, what I hear, again, the details are not important. These are lower bounds for many, many things that one hoped would be there and are not there. Now, for me, I think that with all our will to impose our will on nature, our first mission is to find what is really there. Now, if we can guess what is there and win the guessing game, it's better. But we should know what is really there. And what was found is that the probability at this stage that there are new particles, at least in the channels where people looked like, and they looked at many, many channels, are not there. This is how it looks right now. Okay, now what's next? So there is already a program running, and this program is about high luminosity LHC. The intent is that LHC collect 300 inverse femtobarn. The idea of high luminosity LHC, when it was built at the time, and now this is just my personal interpretation, maybe all the originators will deny, was twofold. Number one, there was a big hope that there would be signs of new particles. So one hoped that anomalies, of course, it's best if, like the Higgs, they would be already with 300 inverse femtobar, you would see resonances. But if not, you would see potential resonances appearing. And then it would be a waste not to, once you already build this machine, not to increase at least tenfold the statistics and see if there, by a factor of square root of 3 or something, if they're more, sorry, square root of 10, is it more reasonable that they are there, that they are really there? So this was one, and this machine is designed to reach 3,000 inverse femtobarn, which would be 10 times the cross section. Number two, people have in mind and think they can do it at the next hadron-hadron machine. The main issue there are finding magnets which can do the job. And high luminosity LHC is a stepping stone in building the magnets for a 100 TeV machine. So it was an excellent opportunity to try and test if one can build better magnets. Now, some of the things I'm saying from knowledge, and some of the things I'm sure you know by yourself to distinguish are parroting what others tell me. So now I'm going to, again, parrot of what someone else tells me. The people who build magnets told me that if you succeed to reach around 12 Tesla from today, this is a breakthrough. And to evolve from 12 to 14, 16 is an evolution. So the idea was to try and see if one can do that at high luminosity LHC. And for several years there was failure, but last year there was success. And now for the first time, it seems that breakthrough was done. So one knows to build now, and and this came as part of the attempts to have the high luminosity LHC, better magnets than one thought a year ago. And that's a very important development in the field. Now, when will it run? So I put question marks because this is for several reasons. First, this is a frontier machine, so problems can happen. Right now, the projection was, okay, oxymoron, but there is a reason why I say it like that, that it will start in 2029. It seems to me right now that it may start in 2030 for various reasons. But I think that's about the window because I think most of the issues are under control. Then comes the question of how long, and how long depends on many issues, in particular on the future plans. So right now, it's designated to run till 2041. But again, these numbers may go, and this time also with a minus. It may be plus, it may be minus, depending on various developments in the field. Now, I want to look at the thing below. That's a magnet built for high luminosity LHC. And this is, again, one of the things which, for me, it just touches me personally. That's it, unashamed. I'm not ashamed of that. So I think if you're in the right age group, we can easily have here a fist fight on who is the better band in the 60s. Is it the Rolling Stones or the Beatles? And you will not find a consensus. I mean, there's going to be a large, I don't want to take here a poll, but I'm sure somebody would say, why think of those? I have much better candidates. And then between those, that or that. Okay. And nevertheless, people from the same culture are able to build together an apparatus which is so sophisticated, agree on it, and put it together, and it works. When I look at it, I moved. Here is an example of
Well,
something.
because they know what they're talking about. If you know about music, you lost already on the first one.
You think that it's easy to agree on a design of a
No,
detector.
no, I'm saying. if they know what they're
Don't,
talking
don't. And the fact that one is able to do it and then build it, and these are each are really high quality, and then they fit together, for me, is exceptional. I must also put Atlas there because Israel's contribution is mainly to Atlas. So, okay, back to where we are and the roads that are involved. So, of course, this is an easy answer. Why not do that? This is what Bjorken said. Bjorken was recruited from Slack by Lederman. He spent there some time and he came with a suggestion. Why not build a 1,000 TV machine? I recommend you read the paper. Nevertheless, that's not what right now on the ground to be decided. So in principle, there are 4 options. 3 of them can be described by geometry. You can have a point, a line, or a circle, or you can do something new. So the point means take what you have already, the tunnel, put back electrons and positrons in order to have a Higgs factory, and put better magnets inside. That's one possibility. Another possibility is build a linear collider between, in 3 stages it's suggested, somewhere between Geneva and increasingly endangering Lausanne at each stage that you do it. That's the line solution. Then there is a circle solution. The circle solution allows to first put in an electron-positron machine and next to put a hadron collider or go directly to a hadron collider. These are what it allows. Then there is new, and I was at a SNOMAD process in the United States, and it's nice in academia to hear usually what the political attitude is, but there I definitely heard Make America Great Again in another language again and again. We need to build a muon collider. We will regain supremacy in the field. This is the feeling I got. That's something new. That's something excited. The rest has already been built. Somebody built an electron-positron collider. People build hadron-hadron colliders. Nobody built a muon collider. Let's do it. So that's the part of the new, and the decision somehow has to be taken between them.
What is this idea of extending the ring around Lake Geneva, a much larger ring than presently? Is that still being considered? And
When do you have to leave?
You don't have to leave?
No, the talk, because we'll come.
Okay, I'll be here. It's too fascinating. I can't.
So it will come. Okay, so when I entered into the council, for me personally it was important to bring council to make a decision on the future. I thought that one has to do it for various reasons, which I'm glad to discuss afterwards. So when I started in one of my it was the first or the second meeting, I said, I'm going to say now 2 statements. This is my observation so far when I was a delegate in council. I'm going to say them everywhere, including a seminar in NYU. And if you object, now is the opportunity. And if not, be silent at least for 3 years. Okay, so number 1, Cern Council is united in the vision of wanting to make sure CERN continues to provide the most interesting scientific program and the most advanced technological tools to do the physics. B, Cern Council does not yet have a consensus on how to actualize this vision. At the time, I think that was correct, and indeed, nobody opposed that, or at least if they did, it didn't reach my ears, so that was it. Now, why do I believe that CERN is the right place to think about doing that? Why is it important to make such a statement? So I looked at the 25 years from 1998 to 2022. And all sums are in unrenormalized. So no inflation, exchange rate fluctuations are not considered. This is just taking. So 29 billion Swiss francs were put into CERN. And I think this number should ring a bell when you think about the future. So the future does not entail order of magnitude change in the funding of the organization. That's a fact. From 1954, Fabiola wanted this number, so okay, it was 53 billion, again, nominal. Now, United States is one country. There are sitting from 12 then to 24 today, different countries. And to have an international organization where all countries, correct till last June, paid exactly 100% of their dues is something which shows commitment. Because these different 24 countries have had totally different economical cycles. And if you know something about Europe, you know that thinking of Greece, Spain, and the United Kingdom is not the same. And nevertheless, all of them paid the money. Moreover, when there was the invasion of the Russian Federation of Ukraine, this, from the point of view of CERN, also brought, because of the energy crisis which came afterwards, and the lack of Russian funding and other parameters, brought a financial crisis. Now, the energy crisis was a crisis of every one of the 23 then countries of CERN. It wasn't particular to CERN. So the initial reaction of many member states says, we suffer, you suffer. We are not going to mitigate it for you. We can't mitigate it for ourselves. So this was the beginning of 2023. By June 2023, I got from Council an agreement to be part of a package agreement, which staff gives a little bit of a salary. CERN changes a little bit its program, and member states put in around 75 million unplanned extra contribution, and it was done. So to me, this ability, I don't know if Aaron Judge will do it, but to step up to the plate and really do something, you look puzzled. No, to really step up to the plate and do something is impressive. So this gives me confidence that there is a will. And in many cases, when there is a will, there is a way. It's a nice slogan. It doesn't always work, but at least I am convinced there is a strong will. And I think member states are realizing that once they became the leading country in the frontier, on the energy frontier, then it also gives you enormous responsibility, because your decisions are shaping what will be done on this planet. And therefore, people are taking it very, very seriously. The last thing which I think helped CERN consolidate CERN is the fact that everything at CERN, the technology, the knowledge, the engineering knowledge is in one place. It's in the US, you had to go from the East Coast to the Midwest, to Texas, back to the Midwest. Not each time a green field, but several times something like a green field, put an enormous burden on the program. And here, it's all concentrated at the same place. I would say that the rock star of today, the guy, the LHC, if FCC will be built, will be the warming band for the big show of the FCC. So it's built one piece of machinery on top of the other, with both hardware and knowledge, human knowledge. And that's an enormous advantage for that. Okay, so question number one is what time is it? And question number two is, how do you build consensus on that? So we started late and so on, so how much do I have? And I will go faster, so.
10 minutes.
Okay. Massimo feels generous today. So, okay. So the procedure is bottom up, similar to your snow mass, not identical, but don't have the time for the differences. You first ask the community what you want to do. Experimentalists have to, unlike theorists, which can flip their loyalty after reading one paper on the archives, experimentalists have their program and they're stuck to it for years and years. So it's a very big responsibility, and you need to know what the community wants. So there is a process to do it. How does it feel in the process? So I showed that it's no mass, but here is what Churchill observed. Why you may take the most gallant sailor, the most intrepid airman, or the most audacious soldier, put them at a table together. What do you get? The sum of all their fears, which is actually correct. However, when you put together the most enlightened government official, the most creative accelerator engineer, the most inventive high-energy experimentalist, and the most brilliant high-energy theoretical physicist, and what you get is the sum of all their fears, but also the sense of all their dreams. And you can feel it in the meetings. It's there. So there were 3 processes which were already done. One was done at Zeuthen, Germany in the past. There the first decision was clear, finish the LHC. Then there was one done at Erice. The decision was clear, milk the LHC as much as you can, and yes, build high-lumi LHC. Then came the third meeting in 2020, the last which happened until now, when it was not easy to reach a conclusion. What one could do is sum up that the community wants a Higgs, a factory to have a Higgs. That's one. The community wants to study the properties of the Higgs. And the community would ask CERN to make a feasibility study if it's possible to build a 100 TeV hadron-hadron machine with a possible first step of electron-positron machine. So what was taken by Council never made a decision, unlike the 2 former ones. Council only decided to do the feasibility, to allow CERN to do the feasibility study, which the Director General volunteered to do. So there was a whole mechanism of how to do it. Again, given the time, be impressed that the process is very rigorous, and the checking. Reading history, I don't think there was ever such a preparation for a machine as was done for this machine. On February 2nd this year, which was after my last visit, there was a decision to allow, management wanted to present a midterm review. As you said, it's a 90.7 kilometer machine. I wanted to be sure it's real, so I asked to be taken on the tour of the machine. Turns out I was the first one who asked that. The other people here really are planning to build the machine, but they did it one at a time. They never had, one of them never visited any place, and the other visited one at a time. So we had the opportunity to see in one day totally different ecological systems. There is a very small place where billionaires in Swiss live, and there is a place in France where it's economically challenged. So the expectations, the way they look at these things are totally different. It was presented to Council, a midterm review with an idea of the future. So a feasibility study will end at 25. It will approved by Council. I won't debate on what that means. A 2041 high luminosity LHC finishes. Operation of FCC starts at 2048 and hadron in 74. How old would be the youngest person in the room?
Maybe 75.
Okay, so feasible. Okay. In order to do it, just to give you a taste, there are 41 communes involved, 31 in France, 10 in Switzerland. You have to go to each of these communes and convince them to dig a hole underneath them, to allow trucks to move around, to clear dust, etc., etc. This is how the machine would look like. So more or less, it's more or less straight, but the topography changes, as you could have seen from the pictures. So in the mountainous area, you have to dig that deep, when there are places where it's very shallow. So the depths of the drillings will be,
So F would be an experimental pond.
yes, there are 8 experimental points in the machine.
Never seen one that deep from the surface. I mean,
Say again,
I've never seen in present machines such a depth from the surface, such a long tunnel.
okay, so let's hope you get to see this depth.
Yeah, because I heard from engineers strange and very mundane problems with doing.
So it's done by professionals, that's all I can say, which have experience in digging tunnels. This is, you asked, so under the lake, around the Salev, this is the places we visited. This is for the EE machine, this is where the experiments will be, and this is for the hadron machine. These are the parameters of first the electron-positron machine. For it, the most important development is that there was a decision to sit on the Z a lot. So to get an unprecedented amount of events, so to be able to study flavor physics with a very high precision. And then there was a problem that to change the configuration of the machine from sitting on the Z, going to the ZH, where one can measure the gauge coupling between the two, it was supposed to take 1 year to change the configuration, and they found a way to do it now continuously. This is the development of the last months. So you won't have to lose a year for that. This is the progress I told you. Then here are parameters of the hadron machine. The ring is the same, but here it's written 90.7. These are the Teslas. If 414, you will get 81. If you have 20, you can go to 115. And this the question is what type of magnets one will be able to build. Okay, here I show various things just to show you that you can do it in PowerPoint. So you have, this is how the tunnel will look for the EE. This is how the configuration will be for the HH. It's 5.5 meters in diameters. And the reason I show you, because it's very easy to produce PowerPoint. I mean, I actually couldn't draw it, but for someone who knows to draw, it's very easy to produce a page before. But in the machine Sesame, which works in Jordan, where Israelis, Iranians, Palestinians, and Jordanians, and Egyptians, and Turks work together, this was the original designs. So I've seen in my life a design, which when I looked at it, I remember saying, on PowerPoint, I can do anything, actually became reality. So I'm not pessimistic that also this can be done. Okay, then a feasibility study was presented in February to Council, a midterm feasibility. I would say in short that, and this is my opinion, okay, don't hold anybody, not Council, nobody. My opinion, already at the midterm, it is clear there is a physics case and it's strong and it's technologically feasible. We can wait till the end, but I think that has been already demonstrated. What has not been yet shown is how to tackle fully the environmental impact, which is a question of the 2 host states. And there are many issues you can ask me afterwards about. There is the issue of sustainability, how not to produce, how to remain as much as you can with 0 carbon emission. And then there is the issue of the funding. I also believe that these challenges are solvable. They're not unsolvable. Then in March, we started building the process. So the process means committees, and committees. The way it will go is in March 2025, management will provide to the European Strategy Group, which I initiated in March, Council initiated in March, it will provide its final report. By the end of January 2026, there will be the final report of the European Strategy Group, and its recommendation would be presented to Council. So from my point of view, at that moment is a decision point, because from then on, Council knows all it needs to know about this. And it can decide not to go on. If it decides not to go on, it should go back and look at something else, or it can go on. But to me, that's a decision point. This is a remit, so the lofty is to find a divisionary and concrete, but that greatly advances human knowledge. And then the strategy update should include the preferred option for the next collider at CERN and prioritized alternative options to be pursued if the chosen preferred plan turns out not to be feasible or competitive. So this is a machinery, you build committees, and they're important, but I will skip them. What about you? So this is a meeting with her family name? Of
Fabiola?
no, Fabiola, I know. Fabiola, I should pronounce it.
Fabiola.
But who is she? She is the deputy, I think, Secretary of Energy of your country. So I know her first name, Regina, but what's her family name? Okay. So I'm not going to describe the P5. I think you had a lecture here of the P5. I even attended by Zoom this lecture, so you know about the American prioritization. After that, there was a signature on intent between the United States and CERN, which essentially says that if CERN will decide to build, the United States will take that offshore option and will join. You had a large meeting in San Francisco, a very large community of near 450 people attended. Then we have the Chinese. This is Yifang Wang, the head of the Chinese program. The Chinese machine is very similar in design to the CERN machine. I visited there. I was very impressed by what they are doing. I believe that an electron-positron machine they can do if they decide to. I can't say if they will do it at the same quality. I can't better or worse. I can't say if they will do it faster or slower, but they have the ability, and I think at this stage, nobody doubts that. I remember that when I was a delegate from Israel and there was a discussion, I raised my hand and I say, why don't you say anything about China? And a very important CERN organization said, I did. FCC is the first Chinese collider. And everybody had a big laugh. I think now people are not laughing about it anymore. I think it's very serious that the Chinese electron-positron collider could be operational. I even would say that one has to very seriously consider that may also be able to build a hadron machine, which is against not the concept. The concept is they can build an electron-positron, they can't build a hadron. And there are strings involved, like the string theory, because it's these coils, which are the coils which cover the magnets, which determine how the things will work. And if you take the basic coils, which I was given, they break like dry spaghetti. So you need to cook them and bring them back, and this becomes, like any good chef, a mystery. It's not already such a well-defined, as Josh was saying before, a process. Here you need the magic. Then in Europe, there was a report which came out a month and something ago. It was given by Draghi, which was an Italian prominent person who was president of the European Bank. And he says in the conclusion that Europe should do everything to preserve CERN. So that's a very strong statement from the point of view of funding. Then we had last month a meeting to celebrate 70 years of CERN. And here is the president of the European Union. She gave a very strong statement in the favor of the place. Now about the physics, that's my last short point. Okay, these things cost money. So funding agency want us to issue insurance policies. But somehow science and discovery is not about issuing insurance policy. The whole point is of the word discovery is not the word confirmation. So insurance policies can be issued, but at a very low scale. What can we promise? Well, we can promise that an HH machine will be able to find out the third derivative of the potential. That we can guarantee. And we can guarantee that we will know if quark-quark or gluon scattering at an energy of 10 TeV obeys the rules of the standard model or not. This we can issue. We don't know it today. We will be able to know it then. The rest is about discovery, and we can't issue an insurance policy. So I hope the Frontier Collider machine, I think it's something that can be done, and I thank you for your patience, but you will need much more of it to wait till this comes. Yes, please.
So you just gave one example of the Higgs potential. But what else beyond the Higgs potential? That's surely not the only important thing.
On my insurance policy, nothing.
Uh,
I can tell you what is not there. This I can promise you, but I can't tell you what is there.
But
Because
you can certainly measure many other things to higher degree, right? They might be as interesting as the Higgs potential.
it could be, but what I'm telling you, one will be able to measure the third derivative. If this I can ensure, and I will put money somewhere in case it fails. Otherwise, I mean, I would say, let me say a few things that I think I want to share with you, you should know. When I visit China, I incur what I believe was the spirit in the Wild West, what I imagined the spirit of the Wild West to be. I hope that I don't live long enough that reconstructions, movies of reconstruction history will take everything out of the romance of that period. So there, when you discuss with the Chinese scientists about a problem, they say, yeah, it's a problem, we'll overcome it. When I'm in labs in Europe and in the US, I see the gravity and the gravitas, not in the good sense of the word, of so much experience, of so many failures, of so many ways taken which didn't work exactly. Everything is difficult. Everything has so many ways it can go wrong. And it's true, but it's not the spirit. It's not the spirit you need on the frontier. That's my feeling. That's
So
okay.
your upgrade magnets or whatever, and the other upgrades that are happening in the present, in the present accelerator rate. What is the maximum energy that you could expect to get and what would be the upgraded energy if you do you have new larger machine under the lake and something? So
I wrote that if you have 14 Tesla, you will be around 80 TeV for proton-proton scattering, and appropriately scaled down for quark-quark scattering. And then if you do if you reach 20, it will be 115. So that's the ballpark in between. But again, my experience is that engineers and theorists are stuck with nature. So we have an idea of what we want things to be, but many times we are correct and many times we are not. Experimentalists, somehow they succeed more to overcome their challenges, even though they're bounds. So in principle, even I never exactly understood why 14 Tesla, for example, or 12, is it bound? I understand it's about tension, about the strength of material. There is a calculation whose result is 12 or 14. But somehow, up till now, looking at new materials, new things, engineers succeeded to surpass. Now, not the fact that they always succeeded in the past does not mean they won't hit a wall in the future. There's no guarantee. But that's,
I mean, in the history of CERN, we saw that there was a decision, let's make CERN, let's be an accelerator. And the same people who made the decision after a few years had the machine running. Now we are talking about the 50-year gap between the moment it's decided whether to go ahead with the machine. So that's a very different process. I mean, even for the people involved at CERN, the people who work at CERN, you have to find, I mean, you have to turn your thumbs a long time before you see the machine.
okay, so this
That's unprecedented.
Yeah, I mentioned it last time, if you remember. I mentioned the point that for the first time, but Massimo was more delicate. I came more to the human nature. So in the past, the people who were in a key position to decide on a machine had a very good chance to be able to claim credit for themselves afterwards that the machine be built. And I think it's an ingredient in human nature when you decide. Maybe some succeed to suppress it more, some succeed to suppress it less, but it is an ingredient in the decision-making process. Even to be able to claim, even though nobody else gives you the credit, you're still able at least to claim that you played the key juncture. This is not the situation now. Now, the persons which are going to make the decisions one way or another have a very, very remote chance to see and be able to claim credit in their lifetime for the success, a particular route they suggested, or a different route that somebody else suggested. And this, what does it mean? It means, guys, it's up to you. I believe strongly that the younger generation should take a more active role in the decision process. Now, how did I try to implement this concretely? My powers are limited, but I can do a little bit. So in Europe, I went first to the United Kingdom, and I asked in a place I knew, and I asked if in that place they're willing to have a meeting, which I will attend only to give input on what council thinks. But they will construct the whole program or under the definition of early career researchers, but I leave the definition to the young generation what they believe is early. Only they are there, and they discuss how they see the future. Are they willing to invest their next 5 years, 10 years in doing simulations on a detector which may never be built, in an accelerator which will never be built? Yes or no, and on what does it depend? And this continued. There are the FCC weeks, so I've been stated that there are sections in the FCC week where early career researchers have their opportunity. And the third thing is that now in the European Strategy Group, it was agreed that in every one of the committee, I flashed through them, but there's for flavor, dark matter, there will be an early career researcher as a secretary, so that the knowledge will be there. Now, in general, and I think here Massimo is a better student of history than me on this, but power is taken, is not given, especially in the world of experimentalists. In theorists, maybe it's more simple, the transition of power. But in experimentalists, there are a lot of resources involved and so on. So power is taken, it's not given. And I think the younger generation should get more involved. That's my personal opinion. That's the only way I can see around this problem. And there are other aspects of the problem. High luminosity LHC, I don't know what physics it produced. I discussed technology. But what it does do, it allows also a generation to do something in the gap. And if you don't allow a physics program in the gap, you will lose the people. And it's not self-evident that people will come back. So it's a big challenge, what you said, both from the point of view of the elder people, that they remember that, but mainly to me for the younger people, because this is for you.
So you're in a situation in which the younger people know that they will never see the LHC, or maybe they'll see that when they are retired or at the end of the career if they have a long life.
No,
So, I mean, you invest, because you're talking about 2070, right? So start working at that.
You mean
point
for hadron,
for
hadron?
the hadron?
Yes.
So of course, you need a spectrum.
No, but you can design, let's say, Massimo, you're now 20, okay, and I'm 20. We could design a machine which could be a detector there.
In 27.
Yeah, but it would, we will be able then to sit in a bar somewhere in Genoa and say, we detected that.
I mean, you will need a lot of intermediate goals besides the lofty goal of seeing a long time after your demise that your idea actually.
Yeah, you would need to be.
Intermediate steps. Now, I don't remember, the high luminosity ends in.
It's built as an intermediate step.
Yeah, but it say tends around 41, 2041.
Yeah.
Then.
No, then there is the E plus E minus
Which
machine.
we start how many years after?
Right now, about 7, but this means nothing. I mean, the numbers now you cannot count. But this is, in our field, this is what happened. Between LHC and LEP, there was a gap. Yes, please.
So, I think that people, if I think about interactions I've had over the years, right? People are much more likely to be happy to invest significant periods of time in something that may happen sometime in the future, if at the same time they're doing something that gives results now.
Okay, you have high Lumi LHC. You can do an experiment there.
Right, but then there are long periods. and
Then you have E plus E minus machine.
So I think some thought needs to be put into what else can be going on at the same time besides these major things to keep people interested. I think it's going to be very hard to take young people and say, you design this thing so that your student can get the physics from it.
But when, I mean, this problem will already arise for the long shot down, so we don't have to.
But there's still data, right? There's still data you can look at, you can do things with, right? But I think it's much harder, at least for me, to imagine people who'd be willing to devote a large fraction of their career for somebody else to read the physics.
It's a challenge.
And I know there's a story of people planting trees now so their grandchildren will benefit from it, but I think that's rare.
I cannot deny. I mean, it's a challenge.
So I'm saying the argument is you need to think about when I say you, the field needs to think about what else can be going on at the same time to make this possible.
I'm all for it, but you first have to decide on, you can, if we spend now all our time discussing, because there are groups which are doing that, only what you are going to do in between, and you are not first assuring there will be the thing in between, it's not the right moment for me now is to reach a decision of where you're aiming. And then you can begin to fill with your imagination. And I also believe there could be points where you change track. There could be, and there are in this program, I didn't enter, but there are points where you could change track depending on many things. I mean, there are many parameters who may change, and you have to have other tracks going out.
So I was also going to ask you a devil's advocate question, which is if you could make a decision about what to do next before or after SLH and C has taken data, which would you prefer?
Say, I did.
If you could decide what to build next after having results from the next LHC, from SLHC or not, wouldn't you be happier to start thinking about what the right decision to make is after you have that?
You mean 27? You're sending me to 2050.
Right, yeah, no, I'm just.
So
Devil's advocate question.
No,
Right?
but
If I'm the politician who has to spend all the money, why did I say, why don't you wait? Let's see what you get from this next machine, then we'll think about what the best track is. It's a devil's advocate question. I'm curious what your response is.
no, I think to build now the E plus E minus machine, we can do it. It's possible. The risks are small. So if you are a politician, I'm sorry, nobody, when you will be re-elected, I don't know, maybe in US Congress, when you sit 50 years on your chair, maybe you will be able to remind. But the president or so on that will be outside his role. But I think to build an E plus E minus machine, that's clear. The moment we have the tunnel, if we have the tunnel, we are really also deciding to build the HH machine or to put something else in that if we have more imagination in the future. But I think the moment you dig this tunnel, you have a horizon of about 50 years ahead of you.
And so you mentioned also the linear collider, and that's gone.
No, nothing is gone. You saw the remit. Let's state what is really the state of affair. The community preferred to try at first the circle solution. Okay, so CERN invested 100 million Swiss francs with the agreement of council, and has now added to it another 39 million. So 139 million with the agreement of council are dedicated solely, and you saw just the tip of the iceberg of the multi ways to deal if you can build an E plus, E minus machine, and what are the potential for an HH circular machine. Now, if the decision would be not to go ahead with that, then one will have to go back and do a feasibility study for the other things. The other things, I think the best race car way to say it, E plus was given by community. The E plus, E minus circular was given the pole position. If the driver in the pole position crashes on the way, then one will have to build do another feasibility study. The data, here, there's a lot, you were saying about friends telling you about digging. So there will be of the order, I think, 30 extra drillings in various places to try and assess if the optimistic statement that 90% are clearly drillable and 10% there is a risk factor. A risk is money. I mean, the tunnel will be built, but the risk is money. So that's which is knowledge, but nobody checked the terrain from Geneva to Lausanne. So but that's a possibility. If the driver in pole position crashes, then one should have another plan, and this is what they're asked to give. If this fails, either they don't think it's realistic, or it will fail in the future, to think of another option. They will come with it. So nothing is dead. But but I would say in pole position is a frontier circular collider. And the others will have to be restudied. That's how I feel about it.
I have a question about it. So you alluded to the muon collider in your talk a little bit. Earlier this year, the U.S. Muon Collider Collaboration was founded. It seems like it has a lot of steam behind it currently. Who knows how it'll actually turn out?
You're talking about the muon collider?
Muon collider.
Yeah.
But so say that gets off the ground in the next 10 or 20 years, gets funding. Does that change CERN's plans at all? Because the science goals are shared to a large degree, right?
That's why I said there are plans of where you can change track. However, in my totally unprofessional opinion, but what I hear from others, a mu plus, mu minus machine cannot be chosen today as a flagship project. It's way too distant in the future. If there will be a breakthrough, fantastic. Actually, when I was Israeli delegate in council, or president of council, usually nobody asked the scientific policy committee in council anything. And I raised a hand and I said, why I want a report from the SPC about the muon collider. So then the president then came to me and told me, how dare you ask such a question without consulting with me? So I told her I don't feel the need to consult with you. Okay, but she was right. Now I know that I was the one which was impertinent, and she was right, because to give a question to the scientific policy committee takes 2 years to answer. And these are very serious people. So you can't just that any young guy, young in experience in this, comes and asks a question. But they did it for 2 years, and their claim was that if you have at the time, that if you have a particle which weighs 3 TeV or higher, and you know it's there, then it would be a better way than doing a hadron collider. If your new particle is less than 3 TeV, then the hadron machine is just as good. That was the answer. It may change. That was 10 years ago. So
And the decision here is gonna be made before we know if the mu will
Right,
work. or not.
absolutely. But that's why I'm talking about contingencies, which it sounds like they have.
I think the place right now which invests most money in muon colliders is CERN. Okay. That's the place where the most serious research done for muon colliders is at CERN. So, if the United States will get 200 million from muon collider, which I think is what I'm told is about what is needed in order to show a demonstrator, then I bless it. I bless the effort and let it go. I mean, the future of our field will be great and bright if one can build a muon collider. But the Holy Grail was not found since the Crusades, and I don't know. I can't have a. It's very tempting, but I don't know if it's real. And the funny thing is that Fermilab, as far as I understand, it issued a death warrant on mu plus mu minus machine about 10, 12 years ago. There was a report and said we stopped that because they were trying to do it, and they issued a death certificate. So now there is a revival. There were good reasons why the death certificate was issued, but it happens since that sometimes people were wrong. Then maybe there will be a way to the future. And that's it. I would be very happy if one could do a mu plus mu minus machine.
Put that up.